All right, for this next section, you're to describe the transformations like we just did in the previous section in order and then write the transformed equation. So I'm just going to recap the order and how you can describe each part. So here, for the, again, this is the general form of a transform function. If your a is greater than 1 or your a is less than 1, we would say that it's a vertical stretch. So I'm going to shorten vertical stretch. I'm going to say vertical stretch by a factor of a. If your a is greater than -1 or your a is less than 1, this should be -1, sorry, then we have what's called a vertical compression by a factor of a. And finally, if your a is less than 0, so it's negative, then you reflect through the x-axis. So the a's you would describe first, and that simply means if for the original coordinates x, y, the transformed coordinate would be x minus y. So you're reflecting the y value through the x-axis. Now, similarly, with slight differences, if your k is greater than 1 or your k is less than -1, we say now this is actually, so it's kind of opposite, horizontal compression by a factor of 1 over k. If your k is greater than -1 or k is less than 1, then we say it's a horizontal stretch by a factor of 1 over k. So I guess what I should mention as well, so this means here the original x values. So if we have an original x value of xy, that would be transformed to x, oops, not k, ay. Where here, the original, so you see here only the y value changed. If it's a k value, that means the original k is transformed by 1 over k, the original x value. And similar to the a value, when your k is less than 0, then you reflect through the y-axis. So you've got your original coordinate xy, transformed would be -xy. Now for the d value, when d is less than 0, then the x value shifts left d units. And when d is greater than 0, we shift right d units. So that would affect your x value. So it's going to be x plus or minus d. And finally, when you have your c, keep it consistent, c less than 0, we're going to shift down by c units. And when your c is greater than 0, we're going to shift the original graph up c units. So there we've got x, y would transform to x, y plus or minus c. So you can see here the a value and the c value affect y, and the k value and the d value affect x. So what we want to keep in mind when we want to describe the transformations are these sayings here. So if we go back to the given equations, we can use those as descriptors. So here, if we're going to look here, first thing you need to do is you need to identify what the different parts are. So if I look here and I compare it to the original function, we see here our a value is negative 2. Our k value is negative 3. Our d value, since this is positive, that means our d value is negative 3. And then our c value is negative 1. So now given that, you're going to come up with the descriptors. So for example, this is greater than 1, so we would say it's a vertical stretch by a factor of 2, but this is negative, so we're also reflecting it in the x-axis. So what you should do now is pause the video and come up with these descriptors. So I'm going to do the same. Alright, so hopefully you took the time to write those out, and now you can compare them to yours. So here we have a vertical stretch by a factor of 2, and we reflect in the x-axis because it's negative. Here we compress by a factor of 1 over 3, and we reflect through the y-axis. Next we shift left 3 units, and finally when c is negative 1, we shift down 1 unit. Now to write the transform function, keeping in mind the parent function, remember f of x for the quadratic is x squared. And don't try to simplify it, just fill in for this the transformation. So we know that our f is x squared here. So everything that has to do with x gets replaced with this. So here we would have our g of x would equal minus 2, and now our f of x, which is minus 3 x plus 3, and that's all squared, minus 1. So you can see here where our f of x, remember, was x squared, the original parent, and that's where you replace the x with everything inside. Alright, let's take a look at the next function and their transformations. Again, recognizing what each value is. So here we have our a is 1 over 2. Our k is the same as the previous question. It's negative 3. Our d value, remember, because this is negative, that means our d is positive. D is 2, and our c is equal to 5. So again, if this is if it's greater than negative 1 and less than 1, then we say it's a vertical compression by a factor of 1 over 2. So pause the video and fill in the rest of the values right now. Alright, so now here we have a vertical compression by a factor of 1/2, horizontal compression by a factor of 1 over 3, and we're reflecting through the y-axis since it's negative. Here we're going to shift right 2 units and shift up 5 units. And writing the transform function by simply replace here, this, remember, is our x squared. So we're placing everything inside for the x. We've got our new transform function is half times -3 x minus 2 all squared plus 5. There, that's it. Go to the next page. All right, now for each of these, you're asked to make a table of values for the parent function, which is f of x equals x squared. Graph the parent function, describe the transformation like we did in the previous question, make a table of values for the image points, and then graph the transform function and write its equation. So a few things. And again, I wrote the sort of the general transformed function here. So we can see here when this is negative, that means we're reflecting through the x-axis. So our a value is -1. So I'm not going to write the descriptions, but you should if you're asked, right? So here you've got your a is -1, so that's reflecting through the x-axis. Here, your k is equal to 2, so that is a horizontal compression by a factor of 1/2. Now, here the first graph, you're going to write the table of values for the parent function. So remember, y is equal to x squared. And you're also asked to write the table of values for the transformed function. Well, given these values, you know your transformed function will equal minus k, your k value is 2x all squared. Okay, so that means your original x values, the transformed one, will be 2x. And here, the transformed y value is going to be -y of the original function. Oops, slight mistake. This would be 1/2 because it's vertically compressed by a factor of 1/2, which means your original x value, if you were to plot it, would then be -1.5. So it's -3 divided by 2, essentially. Then we have -1, -0.5, and then we have 0, 0.5, because that's 1 divided by 2. 2 divided by 2 is 1. 3 divided by 2 is 1.5. And then the y values, they reflect. So your 9 would get transformed to -9. 4 to -4, -1, 0, -1, -4, -9. Again, everything's reflected. So what I'm going to do is I'm going to show the graph using the Desmos program. Just a moment. So I had actually graphed it on the original paper, so you must practice that as well. But here, if I write in the parent function y equals x squared, and we compare that with the transformed function, which was y equals negative, and then we have the brackets here, 2x squared, you can see essentially the transformed graph. So, yep, that's it for now.